Hello, everyone. Good evening, and welcome to DVT207, where we'll be looking at developer experience economics and how we're moving past productivity metrics. My name is Eva Knight, and I am a worldwide go-to-market specialist with our next generation developer experience team. Our team helps customers look at their development processes and understand how you can integrate generative AI tooling into those existing workflows. I'm joined here with Bethany Otto, who is a technical program manager on our Amazon Software Builders Experience team. And we're really excited to be here with you tonight to talk through this session. I know the idea of developer productivity is something that gets brought up a lot, especially in this new time of AI technology. And it's something that our teams are passionate about. We've written blog posts on it this year. Bethany and I's colleagues have presented on this topic the previous two reInvents, but there's been a lot of really exciting breakthroughs that we've had this year that we're excited to introduce you to today. So at a high level, we're going to talk about how we're seeing improvements in the developer experience in this new time with AI technologies. We're going to talk about some of the challenges we're seeing, especially in how we're actually quantifying the impacts of these improvements. And we're going to introduce you to something that we announced this year called the Cost to Serve Software Framework. And this was created by Amazon's Software Builders Experience team and reflects how we actually quantify the impacts of the developer experience with AI technologies in order to better serve our customers. So we're going to hear from Bethany on Amazon's journey in improving the developer experience to ultimately drive improvements for our customers. And finally, we're going to take away some of those lessons learned to help show you how you can potentially take some of these back to your own organization and think about productivity in this time. So the idea of improving the developer experience and increasing productivity isn't a new concept. This is something that since software development was created, we've been trying to find ways to better optimize the developer experience and introduce new ways of working to optimize that workflow. We're all familiar with waterfall and agile methodologies at this point, I hope. We're seeing the rise of DevOps, introducing concepts like CI/CD and containerization, and these are pretty well understood and adopted concepts at this point. And now, with the introduction of AI, we're seeing yet another shift and an introduction of a new way of working for developers. We're seeing that developers are starting to adopt these technologies. But ultimately, these different ways of working each bring different tools, methodologies, processes, but it also brings different metrics in how we actually think about quantifying the impacts of these new technologies. So we're seeing a lot of challenges in how we can actually articulate the impacts that we're seeing with AI technologies. We all know at this point that lines of code does not equate to value. Using that as a metric can really incentivize verbose solutions rather than incentivizing elegant and concise ones. We see that time-based metrics can potentially incentivize corner cutting and oftentimes miss out on elements of quality. And finally, telemetry data, or what individual users are actually doing, fail to show the full picture of what our development teams are actually accomplishing. So, we at Amazon, of course, have a large development team, and ultimately we would love to see increased productivity amongst those teams. We hear from customers that they too want to increase their productivity. This is a pretty well understood idea that is a goal of many. But here at Amazon, we see this as an outcome, and in order to actually impact developer productivity, we need to focus on the developer experience as an input. And the developer experience focuses on the lived experience of developers that focuses not just on quantity, but also aspects of quality in their daily workflows. It takes a more human-centric and holistic approach in actually looking at their day-to-day work. Now, in this time of AI technologies, it's become even more important to think about how you're effectively integrating AI into that developer experience to ultimately drive improvements in developer productivity. Now we have this equation to improve developer productivity, focus on developer experience, and to do so, integrate AI effectively. But we're still left with the question on how do we actually quantify this relationship in a meaningful way? And there's been a lot of thought done on this topic, driven primarily through our ASBX team this year, in trying to understand how we at Amazon can quantify this relationship. Now, ASBX is our Amazon Software Builders Experience team, and for a little bit of a history lesson, back a few years ago, we initially had different teams, each focused on individual tools in the developer experience here at Amazon. Whether it be code build and deployment systems, ticketing, paging, monitoring, knowledge management, each of these different tools were driven by individual teams. But in 2022, we decided to unify all of these tool-based teams towards more of an outcome-based approach, taking the name of the Amazon Software Builders Experience team. Additionally, we introduced a couple different teams under that ASBX organization, some focused on driving insights and metrics and looking at really the developer experience as a whole. Now, the ASBX mission is to really drive what matters with our development teams across Amazon. It takes a more holistic approach and really focuses on enabling developers and maintaining software across Amazon's breadth of services. Now, I know that when my team engages with customers, we're oftentimes running proof of concepts, helping customers test new technologies, and ultimately, we need to help customers be able to go back to their customer and say, so what? What impact did this have on our teams? What outcomes and business value are we seeing with these new tools? I know that when Bethany and her team make improvements in the developer experience here at Amazon, they too need to go to leadership and say, we saw this impact, this is the change that we're ultimately seeing, and give them that so what. And I'd imagine if you're here today, thank you, I'd imagine that you too have had this question, maybe you still do. And so that's why I'm really excited to introduce you to Bethany to walk through what we're doing here at Amazon in order to drive impact and effectively quantify this for our teams. Okay, thanks, Bethany.
Thanks, Eva. So, hi, I'm Bethany Otto. I get to be part of the team that focuses on developers at Amazon. As Eva mentioned, the Amazon Software Builder Experience organization was formed by some existing teams and some new teams. The reason why we did that is we wanted to create better outcomes for our developers. Part of that mission was enabling software builders and with that mission, we have a set of tenets. Tenets at Amazon help teams to align to share the same mental model. This is one of our tenets. You can see providing capacity for teams to reclaim. The words in this tenet matter, and one of those words that is a very important part is that we focus on teams. The reason why we focus on teams is that we actually did an analysis into the indicators of success for developers. And this analysis was over tens of thousands of developers spanning a 5-year time period. And what we found will not be surprising to those of you who have developed software. We actually went out and proved that software development is indeed a team endeavor. Software builders who have a high code review velocity actually return to the mean of their team. What we found was due to the situation, the job function of the team, their current and past decisions with their services, that teams had a predictable velocity. This team velocity is the strongest influencer of individual velocity and perceived productivity. We know that developers join Amazon to create innovations for customers. So as a platform team, one area we focus on is how do we free up developers to make the decisions that matter. We look for ways to eliminate, automate, and assist developers across the full software development lifecycle. We obsess over ways to improve the builder experience, the things that make developers more efficient. So we work backwards from key outcomes. How developers come up to speed faster? How do they build and deploy software easily and safely? All with lower operational toil. We too have a basket of several dozen metrics behind each one of these outcomes. Bridging these outcomes from the company to the team level, we actually work backwards to present to teams the controllable inputs, the things that they have influence on and can control. Well, after our first few years as an organization, we were really excited about continued double-digit improvements. Yet we went to present to the S team. The S team is Andy Jassy's directs, and Brian Ovlosky, our CFO, said, "This is great, but what does Amazon get for this?" Those of you who have been on platform engineering teams, have you heard this before? This may be something that you heard from your CFO or COOs. Well, our story may resonate with you, since simply showing the individual metrics was not enough. We knew we needed a metric that resonated with business value and aligned to that. So how did we accomplish this? Well, I led a small team at Amazon, and I'm going to take you through that story. We knew that traditional method was to add up the teeny time slices of metrics. Small changes do provide value, but they remove friction and frustration. But we know it's not productivity, because 1 minute of time back to a team does not end up in code to production. And often when we add up all of those small bits, we get up to more than 100% time back, so the math just doesn't add up. We needed something better, and we pulled on Amazon's deep history. We found that in our retail business, we had teams that had tackled a similar problem in physical supply chain. They have this metric called cost to serve. You may have read about it in some of our shareholder letters. It essentially is, how much does it cost Amazon to get that box on the customer's doorstep? So, really, what is cost to serve? In supply chain, it's an enormously complex system. There's no single metric, but the core goal is to deliver value to your customer. So the root is, how do you take that unit, package it up, and deliver it? Well, cost to serve looks at the full system, focusing on removing friction, delay, defects, and waste across the entire system. It captures all of the benefits. If you improve your picking efficiencies in your fulfillment centers, if you reduce defects from product damages, if you make improvements to your demand forecasting, all of these benefits get captured in cost to serve. It's an economic measurement of productivity improvement. Well, it turns out this maps very nicely to software, because software is also a complex system. It's much more than just coding. At the root, we have a builder that needs to create and deliver software that provides value to our customers. In this case, there are units, software units that are chosen by the team. I'll touch on that a little bit later. But it's development, not developer productivity. And cost to serve captures the benefits in improving developer experience. You improve your release processes, you centrally remediate risk, you do the things that developers find satisfaction in their job in, you're going to improve your cost to serve. But it works backwards from the software delivered to your customers. It's a number that you can use in your planning and prioritization. So I promise you, only one equation on this. It's very, very simple. At the top, you've got your costs. And at the bottom is your unit of delivery. I will explain unit of delivery. So with that, unit of delivery, for Amazon, we have a bunch of microservices, so we can use normalized production deployments. Yet, for certain businesses, say Prime Video or Store's mobile app, they're going to want to use something that is a proxy of that, and that would be what we call CRs to production. You might call it a pull request. And then you also have other types of teams, like an enterprise team that's committing to trunk. You'd want to look at commits. So that's what software delivery unit is. Underneath this simple equation, we actually apply science and research to understand the quantitative and qualitative values to these metrics and behaviors that are correlated to it. Well, we know that metric is a velocity metric. We know we need to move fast, but we also know we need to not break things. So cost to serve needs to be achieved in tandem with security and resilience. A long-term benefit of cost to serve software is that the costs in maintaining the quality bars of your software are included in that top-level costs. But that's a lagged effect. So we knew we needed to see something in real time that equated that velocity with our quality. So what we did was we created the concept of tension metrics. What are the things that were good indicators of quality that we could look at the same period of time? And we created a handful of those metrics as well. So this balance, one of the metrics that we had that created this balance is high severity tickets. When we looked at this had high precision and recall, so we knew it was something that we could monitor in real time with cost to serve. So you may be wanting to know, how do I apply this to myself? Well, first, we know that you need to make it specific to your team. Software is a socio-technical system, so with that, look at it. How are your teams delivering software? Are they a microservice? Would you do normalized productions? Are they going to be one of your applications or hardware, a software team committing to the hardware? That's going to be your monolithic apps, is going to be PRs. And then your enterprise releases is going to be your commits. So we let our teams choose which value represents their teams the best, and that's what we would show to them. We can also plug in any type of investments that you've already made in measuring your developer experience. So you said, how I said that we had common outcomes that we were trying to drive for our developers. These work with your metrics if you're already applying DORA or SPACE or other types of developer experience frameworks. So you don't need to start from scratch. You can start small, and it also works with, if you want to start small with a local team or start with federated teams, let them choose the metric. So I know that some of you guys will be asking about Goodhart's Law. Goodhart's Law simply states, when the metric becomes the target, it ceases to be a good metric. So you may say, won't teams manage to that metric? We ask this, frankly, about all of our metrics, but teams want to deliver innovation to customers. So we have them obsess over the inputs to that. This is where your input metrics, or those DORA metrics, are key. How do you work backwards from those? A particularly Amazonian concept is mechanisms. Mechanisms are encoded behaviors that facilitate innovative thinking and systemically address recurring challenges. In short, mechanisms help to change good intentions into action and true change. We work backwards from the outputs that we were trying to drive to identify the controllable inputs. What we have teams focus on are those controllable inputs. Are they deploying often? Are they on the latest versions of software? The things that teams have control over and can impact directly. Applying this framework allows you to work backwards from your cost to serve as an output, while having your teams focus and obsess on the inputs or the things that they can control. The power of cost to serve emerges through year-over-year or quarter-over-quarter improvement. What we want to see is that the trend moves down, And this actually creates an interesting resistance to Goodhart's law. So if you have slow teams or you have fast teams, it doesn't matter. It's how is that team in compared to itself over time. The downward trend and the percent improvement of a team is where the value comes. Improvement can be expressed in savings, return on invested capital, or even effective headcount capacity that they get back. So this is your CFO view, your COO view, or your CTO view. Well, as a platform team, we use all three. We've got return on invested capital and the savings for our planning purposes. But what we give to teams is we say with these initiatives, what is it that they are giving back? Or the flip is, what is the opportunity that they're leaving on the table by not doing the initiatives that we bring with them? So with all of the efforts we put towards eliminating, automating, and assisting our developers, what did we do? Let me share some numbers. We were excited about these improvements because, again, we did double-digit improvements year over year. We actually increased weekly production deployments per builder, 18.3%. We made it faster. We made it less manual by reducing the number of human interventions by 30%. And we made it safer by reducing high incident-related tickets per deployment by 32.5. But we still got this question. And this time, we were able to answer. What did Amazon get back? 15.9%. This is not simply velocity. This is a business value metric. This is the total benefit that Amazon got back for their investments in developer experience. Yet, we didn't stop there. We wanted to know, what were the big drivers? We had our scientists look at what actually impacted our cost to serve. And yeah, you're not going to be surprised. CI/CD. We took an initiative to make sure that teams were looking at their pipelines, deploying frequently, all with lower manual interventions. By taking that out to teams, we did affect our cost to serve. Another thing is managed abstractions. We've got managed capacity, managed fleets, and managed services. And then, of course, generative AI. We see the benefits increasing quarterly, especially now with Kiro. Yet, this is beyond code authored. It moves into the full breadth of the SDLC with agentic AI. Cost to serve captures all of these benefits. And one of the things we're seeing is that the teams with the biggest changes are the teams who have become AI native. Teams who are AI native with software development are using AI throughout the SDLC. This involves a fundamental shift in how software is designed, developed, and maintained, all handling tasks from ideating through to long-term autonomous maintenance. The teams focus on a goal to build more adaptive, intelligent, and efficient software by leveraging AI's capabilities to manage complexity and continuous change are those that are gaining these efficiencies. So, stepping back, historically, a team would start with a plan, complete a BRD or maybe a high-level design before they wrote any lines of code. Then, once they had authored the code, they would test it, release it, ensure it was stable, and then have to maintain it. This loop was the SDLC. What we're seeing now is that the SDLC is becoming two loops that are becoming tighter. You've got your plan, develop, test, and your release, monitor, and operate. With AI software development, once we have an idea, we can fast track to a prototype and then have AI generate a more detailed plan from that. Developers are now engaging in fluid dialogue with agents to shape the requirements and architectures first. They can express concepts in natural language, explore trade-offs, and watch solutions take shape, all before writing code. That detailed AI-generated plan includes relevant requirements, architecture choices, data handling details, and error handling strategies, along with tests. Our internal AI-powered planning systems will provide real-time visibility across all work at all levels of the organization. The tools will update documentation along the way as well. Software developers will spend more time developing software because we are eliminating or automating more of the undifferentiated work, including software maintenance and upgrades. Developers are generating more features, but our AI code maintenance systems will create millions more software changes to release. So we won't be able to use AI to generate millions of code changes unless we have a safe release process that is completely free from manual interventions, which means no failed builds, no failed tests, at least failures that require manual interventions. AI will automate our event remediation. When it can't do that, it will assist our operators with more data and insights so that they can reduce the event duration. AI will also look for root causes and suggest upstream fixes to software to eliminate future events. Remember, as a platform team, an area we focus on is how do we free up developers to make the decisions that matter. We have been focusing on what we can eliminate, automate, or assist for our developers, the things that make developers more efficient. So how are we going to deliver that? Well, at Amazon, we leverage these building blocks that are necessary for us to reach this AI native software development. Over the past few years, we have seen our internal Amazon developers adopt AI tools, starting with QIDE, then to QCLI, and now Kiro. These are synchronous AI agents, or AI assistants, that are embedded in the tools that developers are using to interact with AI and agents, like an IDE, CLI, or even a website. We even have a team that integrated Q Business for knowledge discovery. Our team saw an issue where the developers had two common surfaces where they asked questions: our internal QA site, a tool called Sage, and relevant Slack channels. Yet, in both cases, developers had to wait for an answer. Our ASBX team saw this as an opportunity. We wanted to better assist our developers to remove that wait time. And our integration with Q Business allowed our solution to pass rigorous security and privacy bars, along with scaling to support to the volume of documentation and questions that Amazon developers generate. The result has helped tens of thousands of Amazon developers answer questions and get back to building. We also integrate assistance in other phases of our release process, of our software lifecycle. The release assistants that help fix a broken release pipeline, or our on-call assistants to help remediate an issue builders have operating their service. These are internal tools that existed before AI that we are now using AI to complete tasks. With AI, we can move beyond simply assisting with tasks, and we continue to build synchronous workflow agents that will perform work on behalf of our developers, sometimes without their interaction. Software maintenance is one of the big areas for us. Code transformations is one of those examples. We don't need to involve a software builder in every migration. You may have read last year that we took a goal to migrate our pipelines from JDK 8 and 11 to 17 plus. Well, we did that with the assistance of Q code transformation. This allowed us to eliminate the heavy lifting of code transformations and move it to simply automating the complete end-to-end process of upgrading and modernizing applications. This significantly reduced the time and costs associated with transformation projects while enhancing security and performance. Yet, that is one, and this year we have used AWS Code Transform, this technology, to do multiple dozens of these all at the same time. Initially, an agent might require a review from a builder, but the key is to continue improving workflow agents so that they become autonomous over time. Otherwise, we'll overload our developers with more work. Well, agents can't perform expert work without the right foundational models. We saw a transformational shift in our use of AI earlier this year as new models came out, And we regularly evaluate models and have a curated list of what we support and recommend to teams based on multiple factors. But even the best available tools and models don't work out of the box on the software and tools that we've accumulated over the last 30 years. We have new and legacy software. We have a wide and diverse set of businesses, even some with their own bespoke tools and specialized needs. This is where we are investing the most, integrating our internal tools and software ecosystems into AI agents. The tools and agents won't work without expert foundational models, right? So this is where we use Amazon Bedrock, incorporate the latest, greatest models into all of our software tools and systems. And it's been really amazing to see the advances in the foundational models that we get to use. But even that's not enough. We need to do the internal Amazon integration so that the AI tools and the foundational models understand our Amazon systems. This is where we're leveraging MCP across the entire company. So the AI tools understand what a Brazil build is, our pipeline release processes, or Git farm source control, those things. And this is something that all AWS customers will also have to reconcile with as well, right? Especially enterprise customers. How do you get the AI tools out of the box to understand your bespoke systems? This is how we do it. Today, our developers still spend too much time providing manual context to get our tools to work. We have communities of practice sharing ideas and context files among team members. A lot of this is new, undifferentiated work, but we're still a large organization and there's no one-size-fits-all context. So we focus on peer-to-peer learning mechanisms like internal events and demos. And we build mechanisms so that we're constantly improving the knowledge of our tools, agents, and models so they don't become stuck in time. The way we approach building this knowledge is through a model we use for software development across Amazon. It's the core. These are the things that are applicable to all of Amazon, like what source control to use, how to apply to code review, or releasing software safely. Then we have common, like what tools and architectures we recommend for web services or for the store's mobile application. And lastly, we have custom. These are team-specific guidance, all with the goal of reducing manual context and shared knowledge. So, as you may know, adopting AI is not without its issues and challenges. So let me share with you some of our learnings. How many of you guys can relate to this? Raise your hands. Yes. AI does not simply make the entire business go faster. Yet, in being intentional in how you approach your AI adoption is key to successful improvements in getting innovation to your customers. Our mental model is eliminating undifferentiated work wherever possible, like simplifying an architecture or code base, using managed compute over hosts. How can we eliminate paging an operator? Where we can't eliminate undifferentiated work, we look for ways to automate it, like software migrations or automatically remediating an alarm. And then we use AI to assist builders in their remaining differentiated work, like inventing for customers. Measuring lines of code does not get you AI productivity numbers. Also, much of AI productivity numbers claims are based on simple greenfield projects, which don't translate to true team outcomes. The reality is, development tasks are mostly brownfield coding and bug fixes. Developers work in complex custom code bases with years of embedded knowledge. Modern developers own their own products and features end to end. They do analysis, design, customer support, operations, not just coding. And large enterprises always have bureaucracy and friction that prevents theoretical benefits from being realized. But we can use AI to reduce the day-to-day friction if we take a holistic view of product development. Understand the fundamental concepts, context, models, and agents. Lean in where there is willingness and patience to experiment. Just like how your developer experience impacts agents, security and safety mechanisms are needed to protect work done by agents, especially in the release and operate workflows, where doing the wrong thing will impact your customers. Everything is moving quickly. Agents are moving fast. There aren't always best practices. It's important to ground your work in the overall developer experience and the metrics we've established. So here are some of the metrics we look at to see where there is friction in the developer experience. Use these as common balances to see where there are patterns or hidden issues that could be addressed. Remember when I said we had tension metrics for cost to serve software? Well, one of these is high severity tickets. Well, actually, the really name is human actioned high severity tickets per normalized deployments. It's a mouthful, right? What we found with this is we first looked at high severity tickets, but that was just a count, and it wasn't in relation to cost to serve or the normalized deployments. So then we put high severity tickets per normalized deployments. But then we found out that a lot of bots were affecting our high severity tickets. So we had to move those out to truly have an indicator of quality. So that's why we have human actioned high severity tickets per normalized deployments. Why I went through that is because metrics mature over time. I know that what we've presented today is very advanced, and maybe some of you don't have an idea of where to start with your developer experience. But wherever you start is a starting point for you and will progress forward. So if your metrics need to mature over time, let them. There are many different metrics that we look at for AI outcomes. We look at leading and lagging indicators of AI. Yet, we don't just look at quantitative metrics. Give it a minute for the pictures. So, since quantitative metrics don't capture enough nuance, we have a team of researchers that look at and use qualitative metrics and anecdotes to find the paper cuts in our tooling. This adds color to what the metrics are telling us. This helps us create a holistic view into our approach and is changing our developer experience across Amazon. And we share these metrics to our organization so they can use them to improve as well. And here's a recent quote from one of our customers. She says, ASBS metrics combined with the qualitative metrics from the tech survey insights have been instrumental in improving their builder experience strategy. She goes on to say, quantitative data showed where AI tool adoption was strong, but velocity outcomes uneven, while qualitative feedback revealed why. This guided investments in AI native transformation and operational automation, helping us build the right mix of centralized and differentiated tools to measurably improve their developer velocity and operational excellence. I know this was a lot, so let me do a quick recap. You can show economic value of improving your developer experience. It's much more than lines of code. We know that there is value in capturing all the improvements across the full software development lifecycle. Tailor your approach to your teams. Start small, start where you can. Use metrics to prioritize investments and encourage adoption of the technical investments you know will improve the outcomes for developers. And look for ways you can eliminate, automate, and assist your developers. So I'm going to invite Eva back up onto the stage because we have more than this presentation that we wanted to introduce you to.
Yeah. Thanks, Bethany, for taking the time to share Amazon's story with their development workflows. I know we get asked all the time from customers how Amazon themselves are thinking about this, and so we appreciate you taking the time and driving improvements across our development teams. And it seems that these concepts are really resonating with our own customers. So I encourage you to take a picture of that if you haven't already. And if you're interested in learning more on this topic, there were a couple sessions earlier this week. There was DVT207 that took place on Monday, And this session really walked through more of a tactical example of how a customer today is measuring the impact of tools like Amazon Q Developer and Kiro, and how they're quantifying those impacts. Similarly, there was another session earlier today, DEV323, which walked through Prime Video's journey in a deeper session. So I encourage you to watch both of those videos once they're available on YouTube later this week. And if any of you are interested, there's one that you can attend later this week. There's multiple, but one that we recommend, and that is our innovation session taking place on Thursday. And that's going to look at some of the new launches that we announced today, if any of you saw those announcements in the keynote, and how we're thinking about reinventing software development with these AI agents and continuing to think about developer productivity and improving the developer experience. Additionally, more specific to this topic, we have a few blogs that were released earlier this week. We have one on the left here that was produced by our Amazon Science team, and it walks through how we're measuring the effectiveness of software development with different tools and practices. And another blog there in the middle was released by Bethany and her team, walking through this cost to serve software framework you saw today and how we ultimately got to that 15.9% improvement. And finally, on the end there was a podcast done similarly by Bethany's team that walks through this story as well. So whatever medium you want to consume, I encourage you to take a look at those. But Bethany and I will be outside in the hallway should you have any questions and want to talk further about this. But we really appreciate you taking the time on your Tuesday evening to sit with us, talk about developer productivity, and we hope you have a great rest of your week here at reInvent. So thank you.